Section 1.8 will start off with another couple of definitions. We're going to be using the word term a lot in class, so we need to have a common definition of what we mean when we say a term. So the word term in algebra means a collection of numbers, variables, and or exponents connected with multiplication or division. Okay. Again, the definition sounds kind of abstract, hard to understand, but I'm going to give you some examples over here that should make more sense. Note that they are not connected with addition or subtraction. Something that has an addition or subtraction between it would actually make it two separate terms. So if we look at some things that are terms, terms are defined as something that are a collection of numbers and or variables and or exponents. So 7, just the digit 7 all by itself, would be considered a term because it is a number. And because of this word or, we don't have to have a variable with it to make it a term. -1/2 is also a number, so it fits our definition of term. The letter x, all by itself, fits the definition of term. We could also take our 7 and our x and connect them together, and they would still be a term because this is a collection of a number and a variable, and it's connected with multiplication. The other thing that can be included is an exponent. So if we have x squared or 7x squared, all of those things are terms. To use up our half a little bit, a -1/2 x or a -1/2 x squared, all of those would be considered terms. Things that are not terms are things that are connected with addition. So while 7 is a term by itself and x is a term by itself, if you connect them with addition, they're no longer considered a term when grouped together. They are individually terms, but the expression 7 plus x would not be considered a term. Okay? Or if we took our 7x and subtracted x squared. The 7x is a term, the x squared is a term, but the two grouped together do not represent a single term. They represent two terms that are being attached with subtraction. Coefficient is a number, another word that we're going to hear a lot, and a coefficient is the number part of a term. And I'm going to put one more note on this one. Note, a term that is just a number, doesn't have any variables attached, is called a constant. So when we're talking about the number part of a term, in our term 7x, or our term 7x squared, or the term -1/2 x or -1/2 x squared, the 7 is the coefficient. in both of these cases. And in this case, if I can't spell coefficient, there we go. In this case, the negative 1/2 is the coefficient. So in this example, I'm asking you to list the terms and the coefficients in these different groups. So the terms would be 12x squared y, then a comma, because our next term is going to be a negative xy squared. Notice that this subtraction right here ends up traveling with its term when you write it down. The next term in our list is a 7x. The next term in our list is a negative 3/4 y. And the final term in our list is a 20. So those are our terms. The coefficients are just the number parts of each one of these terms. So the number part of each of these terms, we have a coefficient of 12. Here, if you think back to the previous set of properties, when we had a negative that got distributed, I told you you could write that as a negative 1. You can also do that if you think of the multiplicative identity. Multiplying something by 1 does not change its value, so it's always legal to do that. So our coefficient on the term negative xy squared is a negative 1. Our next coefficient is a 7. This coefficient is a negative 3/4. And we don't include the 20 as a coefficient because 20 is a constant, not a coefficient. Okay. The final definition for this page is looking at what it means to be a like term. Like terms are terms whose variable parts match. Their coefficients do not have to match. So a like term has identical variable parts. And the note for this is coefficients don't need to match. Okay. So the term 7x squared and the term negative 1/2 x squared are like terms because they both have an x squared as their variable parts. Unlike terms would be something like 7, 7x, and 7x squared. They have matching coefficients, but the note says the coefficients don't have to match. The part that has to match is the variable part. And this one doesn't have an x, this one only has one x, and this one has two x's getting multiplied together. So these would be considered unlike terms. So if we separate our group down here into like terms, remember I'm looking only at the variable parts. So this variable has a coefficient of 1, it's 1x. Here is a 3x, and here is a negative 1/2 x. So I'm going to put those three on a list together. X, 3x, and negative 1/2 x are all like terms. It also looks like I have a couple of constants, a negative 7 and a negative 1/2. So they are like terms because their variable parts are alike in the fact that they don't have any. So a negative 7 and a negative 1/2 are going to be grouped together. My next set of terms are the x squared terms, Looks like there's an x squared there and a negative 7x squared at the end. Again, matching variable parts. You'll notice that I didn't group the y squared terms because even though they have squares on them, their variables are not the same. This one has 2 x's, this one has 2 y's. So those are going to be in a list by themselves. And then it looks like our last collection are going to be the terms that just have a single y on them. So my last group is a negative 1/2 y and a negative 7y.